This is the story of one of the most overlooked industries on the planet, global tire manufacturing. Every car, truck, bus, airplane, and bicycle on Earth depends on it. Over 2.5 billion tires get manufactured every single year. The global tire market is worth somewhere between $143 and $207 billion, depending on who you ask, and it's projected to keep climbing well past $250 billion by the early 2030s. Yet most people never think twice about the 4 rubber circles keeping them alive at highway speed. So let's change that. The tire industry touches everything. It consumes staggering quantities of natural rubber, petroleum, steel, and chemicals. It shapes geopolitics, drives environmental controversy, and sits at the center of one of the most significant pollution crises you've probably never heard of. And right now, it's undergoing a transformation that could redefine what a tire even is. Let's start at the beginning. The year is 1839, and an American inventor named Charles Goodyear has just made one of the most consequential accidents in industrial history. He's been obsessing over rubber for years, trying to figure out how to make it durable enough for practical use. Raw rubber is sticky in summer and brittle in winter. It's basically useless. Then Goodyear drops a mixture of India rubber and sulfur onto a hot stove. Instead of melting into a mess, the rubber transforms. It becomes firm, flexible, and resilient. He's just discovered vulcanization, the chemical process of curing rubber with heat, and he's done it completely by accident. By 1844, Goodyear would patent this revolutionary process, laying the foundation for an industry worth hundreds of billions of dollars today. But it took another half-century for someone to figure out what to actually do with it. In 1845, an Englishman named Robert Thomson had a clever idea. He imagined an air-filled tube placed between a carriage wheel and the road to cushion the ride. He even patented it. But his design was crude, basically a rubber tube wrapped in leather, and the world wasn't ready. The idea vanished almost immediately. 43 years later, a Scottish veterinarian named John Boyd Dunlop was watching his young son bounce painfully along the cobblestone streets of Belfast on a bicycle with solid rubber tires. The boy complained about the harsh ride, and Dunlop, being both a loving father and a practical man, decided to do something about it. In 1888, he developed the first truly practical pneumatic tire, an air-filled rubber tube that provided cushioning and grip far beyond anything available at the time. The following year, a cyclist named Willie Hume took Dunlop's tires to the races and won every single event at the Queen's College Sports in Belfast. The pneumatic tire had proven itself, and the world noticed. Here's the twist, though. 2 years after Dunlop was granted his patent, he was officially informed that it was invalid. Robert Thomson had patented essentially the same idea decades earlier in France and the United States. Dunlop had independently reinvented a forgotten technology. But history tends to reward those whose timing is right, and Dunlop's name stuck. He was posthumously inducted into the Automotive Hall of Fame in 2005 and the Inventors Hall of Fame in 2006. His tire company would eventually become a subsidiary of Goodyear in 1999. Meanwhile, across the English Channel, 2 French brothers were paying very close attention. André and Edouard Michelin had established themselves in the bicycle tire business, winning races all over continental Europe, including a grueling 750-mile race from Paris to Brest and back in 1891. But they had bigger ambitions. By 1895, Michelin had created the world's first pneumatic tires for automobiles, and the modern tire industry was truly born. Fast forward to 1968. Consumer Reports published findings declaring the superiority of radial tire design over the bias-ply tires Americans had been using for decades. Radial tires, which had been developed in Europe years earlier, offered better fuel efficiency, longer tread life, and superior handling. After that announcement, radials began an unstoppable climb, capturing 100% of the North American market by the 1980s. Today, radial tires account for roughly 75% of the entire global market. So how exactly do you make a modern tire? It's more complex than you might think. A modern car tire typically contains around 25 individual components and up to 12 distinct rubber compounds. The main raw materials are natural rubber, synthetic rubber, carbon black, and oil. The share of rubber compounds in a tire's total weight exceeds 80%, and approximately half of that rubber is natural rubber harvested from rubber trees. Here's a number that might surprise you. Tires consist of about 20% natural rubber and 24% synthetic rubber, and that synthetic rubber requires roughly 5 gallons of petroleum per tire. The rest is a cocktail of steel, fillers, and heavy metals including copper, cadmium, lead, and zinc. The textile industry supplies base materials like rayon, nylon, polyester, and aramid fibers, which get woven into cords that serve as reinforcement. All of these materials come together in around 455 tire factories scattered across the globe. The manufacturing process follows relatively standardized procedures. Raw materials are mixed, components are layered and assembled on a building drum, and then the whole assembly goes into a curing press. In there, temperatures reach about 350 degrees Fahrenheit with pressures around 350 psi. For a passenger car tire, this vulcanization process takes approximately 12 to 16 minutes. But for off-road and large industrial tires, curing can take up to an entire day because of their sheer size. And the output of all these factories is truly massive. Over 2.5 billion tires roll off production lines every year. Since 2019, at least 3 billion tires have been sold globally per year. Now, who controls all of this? The tire industry is dominated by a handful of giants. Michelin, Bridgestone, Goodyear, and Continental have held the top 4 positions for years. Pirelli has climbed to 5th, marking significant growth. Rounding out the global top 10 are manufacturers like Yokohama Rubber, Sumitomo Rubber, and Toyo Tires, which continue to expand their international presence. Together, the top 5 manufacturers hold nearly 50% of the entire global market. Companies ranked 6 through 10 account for about another 10%, leaving the remaining 40% split among everyone else. Michelin leads the pack with roughly 14 to 15% global market share by sales, and Bridgestone sits right behind at 13 to 14%. In 2024, Bridgestone generated total revenue of approximately $31 billion. Goodyear brought in $17.47 billion. Continental, which is a much larger conglomerate beyond just tires, generated total revenue of about $43.6 billion across all its divisions. But here's where the landscape is shifting. Almost half of the top 75 tire manufacturers in the world are now based in China. Chinese companies have been climbing the rankings fast. Salon Group, for instance, entered the top 10 for the first time recently, after being ranked just 17th in 2020. The Asia-Pacific region dominates the global market with roughly 44 to 48% of total revenue. In 2023 alone, China, India, and Japan accounted for 72% of the Asian tire market, producing 1.3 billion tires valued at $97.4 billion. And the aftermarket is where the real money flows. Based on distribution channel, the aftermarket segment led the market with 63.3% of revenue in 2024. Think about it. You buy original equipment tires once when you buy a car, but over the life of that vehicle, you'll replace those tires multiple times. In the United States alone, 257.6 million passenger vehicle tires were shipped in 2022, according to the USTMA. And of those, 216.1 million were replacement tires versus just 41.5 million original equipment tires. The aftermarket outnumbers original equipment shipments by more than 5 to 1. Now let's talk about the part of this industry that almost nobody discusses, the environmental cost. Here's a statistic that should stop you in your tracks. Tire wear particles account for an estimated 28% of all microplastics entering the global environment. Some studies place that figure even higher, at around 45% of all microplastics in both terrestrial and aquatic systems. Every year, an estimated 6 million tons of tire fragments are shed from vehicles worldwide. Tiny particles end up in soil, rivers, lakes, oceans, and yes, in our food. One report from the Pew Charitable Trust in 2020 found that 78% of microplastics in the ocean come from tires. And this isn't some niche concern. This is billions of vehicles every single day grinding their tires against asphalt and releasing invisible clouds of plastic and chemical particles into the environment. And it gets worse. In 2020, researchers finally solved a mystery that had been plaguing the Pacific Northwest for decades. Why were coho salmon dying in massive numbers after rainstorms? The culprit was a chemical called 6-PPD, which is added to virtually all tires to prevent cracking and degradation. When 6-PPD encounters ground-level ozone, it transforms into a compound called 6-PPD-quinone. Cassandra Johannesson, a researcher at Concordia University in Montreal, put it bluntly. 6-PPD-quinone is one of the most toxic substances known, and it seems to be everywhere in the world. It's acutely lethal to multiple fish species, and it washes off roads into waterways every time it rains. California has already responded, passing a rule requiring tire manufacturers to declare an alternative to 6-PPD. And in the EU, new Euro 7 regulations taking effect from 2025 will be the first emission standards in the world to set limits for both brake particulate emissions and microplastic emissions from tires. And here's the paradox that makes all of this even more complicated. Electric vehicles, the ones we're told are the future of clean transportation, are actually worse when it comes to tire pollution. Their batteries make them significantly heavier than comparable combustion engine vehicles. That extra weight, combined with the instant torque electric vehicles deliver, causes tires to wear approximately 20% faster. Tire emissions from electric vehicles are 20% higher than those from fossil fuel vehicles. The EV tire market itself is booming. It's expected to grow from $11.21 billion in 2025 to $27.36 billion by 2032, a compound annual growth rate of 13.6%. Manufacturers are racing to develop specialized EV tires with reinforced sidewalls, advanced compounds, sound-absorbing technology, and run-flat tire capabilities for enhanced safety. TPMS systems have become increasingly sophisticated to handle the unique demands of electric vehicle weight distribution. In May 2025, Pirelli introduced the P0 fifth-generation tire, designed specifically for electric vehicles with AI-driven tread patterns. In April 2025, Bridgestone launched the Turanza 6 with its Enlighten technology for reduced weight and rolling resistance. But no matter how advanced these tires get, they still wear down. And that brings us to the waste problem. In the United States alone, 317 million waste tires are discarded every year. That's 9 tires every single second. Globally, about 1 billion end-of-life tires are generated annually, with an estimated 4 billion already stockpiled in landfills. That number is expected to reach 5 billion by 2030. The good news is that tire recycling is improving. The USTMA reported in 2024 that 79% of end-of-life tires in the US are now being consumed by end-use markets, a 10.5% increase in overall utilization. Tires actually outpace metal, glass, aluminum, plastic, and paper in recycling rates. Liberty Tire Recycling alone collected over 215 million end-of-life tires in 2024 and reclaimed over 4.7 billion pounds of rubber. The EU has made even more progress. The proportion of end-of-life tires sent to landfills in Europe dropped from 50% in 1996 to just 4% by 2015. By 2019, approximately 95% of end-of-life tires in the EU were collected, with 55% going to material recovery and 40% to energy recovery. In February 2024, Michelin partnered with Antene and Enviro to build dedicated tire recycling plants across Europe, with the first facility in Sweden expected to go operational in 2025. The global tire recycling market itself was valued at about $5.5 billion in 2024 and is projected to reach $9.5 billion by 2034. But the most radical solution to the tire problem isn't better recycling, it's reinventing the tire entirely. Michelin has been developing what it calls the Tweel, a portmanteau of tire and wheel. It's an airless design where the hub connects to the rim via flexible polyurethane spokes instead of compressed air. It can't burst, it can't leak, it can't go flat. And because it eliminates the air bladder entirely, it removes one of the most common failure points in conventional tires: Michelin has had a version available commercially since 2012 for off-road and specialty vehicles. For passenger cars, Michelin developed UPTIS, the unique puncture-proof tire system. General Motors partnered with Michelin with plans to introduce airless tires on production passenger vehicles. And here's the number that really matters. Michelin expects the tread on airless tires to last 2 to 3 times as long as a conventional tire. If that holds true at scale, it could dramatically reduce both raw material consumption and waste generation. The technology has even caught NASA's attention. The space agency contracted Michelin to develop a wheel for the next generation lunar rover based on the Tweel concept. Meanwhile, the industry continues pushing towards sustainability in other ways. In May 2024, Michelin launched its first carbon-neutral tire production line at its facility in Pune, India. In South Korea, Hankook partnered with Hyosung and SK Chemicals to create an EV-exclusive tire incorporating 45% renewable materials. Nokian Tires introduced a concept tire using bio-based renewable functional fillers. So where does this leave us? The tire industry is massive, essential, and deeply problematic all at once. It keeps the world moving. Over 2.5 billion tires a year, supporting everything from daily commutes to global supply chains. But every mile driven grinds away a little more rubber, sending millions of tons of microplastics and toxic chemicals into the environment annually. The industry knows this. The regulators know this. And slowly, change is coming. Better recycling infrastructure, cleaner chemicals, tires made from renewable materials, airless designs that last 2 to 3 times longer. But the scale of the challenge is enormous. A passenger tire loses nearly 2.5 pounds of rubber over its service life. Multiply that by billions of tires, and you begin to understand why this quiet, unglamorous industry deserves far more attention than it gets. The next time you're driving and you hear that faint hum of rubber on asphalt, remember, you're listening to a $150 billion industry at work. One that began with a father trying to give his son a smoother bicycle ride, and one that is now racing to solve problems its own success created. And speaking of tire technology that most people never think about, if you've ever wondered what actually happens when a run-flat tire takes a hit, and why the dealership might not be telling you the full story, that's exactly what we're covering next.